Hey everybody, welcome back to Mr. Curl's Classroom. Today we're going to talk about solving absolute value inequalities. So let's get started. Okay, so on my screen I have a representation of two different absolute value inequalities. The first one in pink has a greater than or equal sign, and the next one in green has a greater than sign, and they both have an absolute value inside of them. As with all of mathematics, whenever you're solving something algebraically and you want to undo something complicated, something like an absolute value, you want to isolate that. Isolate it is pretty much always the first step. So step one is to isolate, and you can see here I have in the pink I have done the steps where I am going to subtract one from the other side. So negative one minus negative 5 minus 1 is negative 6. Then I need to divide by negative 2. Um, Notice that I switched the sign. Whenever you divide or multiply an inequality by a negative, you have to reverse the sign. So that greater than or equal to became a less than or equal to. All right, and now this one in pink has been isolated. We have isolated the absolute value on the left-hand side. The one in green was a little bit easier. All we had to do was subtract 3 from both sides, and we ended up with the absolute value of x minus 2 is greater than negative 3. All right, so step 1 was isolate. Now the next step for any type of absolute value inequality is actually to determine whether it's an and or an or. Okay, so what does that mean? Well, there are a few different ways that you could determine this. The way that I like to use, just because I think it's easy, I don't like to use tricks or anything like that, but for some reason, this one is always stuck in my head, and it seems to help students quite a bit as well. So the rule that I use, if you look over here, is to determine an and or an or. If the sign, the inequality sign, is a less than or equal to or less than, then it is less than, right? Less than or equal to, less than. And so that way it is an and. And if it is a greater than or equals to sign or a greater than sign, then it is great or. Great or. So it is an or. Now, there are a lot of different logic skills that you could apply here, but I don't think we should really get into that much depth for these types of problems, discussing logic and everything like that. So anyway, so for now, I think we can just simply use this little saying here, less than, great or. And we'll talk about what it means to be an and or an or in a second, okay? All right. So the next step is really the same as any type of equality, an absolute value equality. And we're just going to go ahead and develop the two cases for each one of these. So just like an absolute value equation, what do we do for the first case? Well, we simply rewrite the entire equation, but just drop out the absolute value sign. Well, in this case, for an inequality, it's the same. So x plus 3 is less than or equal to 3. So just rewrite it. The second case is actually quite similar to the second case for an equation. We are going to reverse the number on the right hand side, the sign of the number, I should say, and then we are also going to reverse this inequality sign as well. Okay, so in fact, you can see right here that I'm flipping the sign on the number, and I'm also flipping the inequality. And it's the same for the one in green because it's just an absolute value inequality, just like everything else. First case, you're just going to rewrite the inequality. Second case, we are going to rewrite it, but we're going to flip the sign of the number and also the inequality as well. Okay? All right. So from here, it's still the same as an absolute value equation. We are going to simply solve or simplify each one of these. So, when I simplify these, you can see that I bring this 3 over, so x is less than or equal to 0, and we haven't talked about what that means yet, but and x is greater than or equal to negative 6. And for the green one, we get x is greater than negative 1 when I add that 2 over, or x is less than 5 when I add that 2 to the 3. Okay? All right. Now, technically speaking, these are your solutions. This is if I told you to please write your answer as an inequality, this would be your solution. However, one thing you should note is that sometimes you may write an and like this, because with an and x is the x is really in between two of these numbers. In fact, it's greater than or equal to -6. We always start at the lowest end and then move over. So anyway, x is greater than or equal to -6, and x is less than or equal to 0. So you may see, you may write your answer like this, and you might see answers written like this. But this is really kind of hiding the fact that this really is an and, okay? So anyway, so I just want to point that out. All right, let's remove that. Okay, so this is one way to write your answer. If I asked you to write your answer as an inequality or in inequality notation, this is how you would do it. But there are actually 3 other ways to write this solution. The first way is with a number line. And since I'm kind of running out of room here, I'll do one at a time. But anyway, so let's do the pink one first. All right, so if I was utilizing a number line here, I would go ahead and put in, the appropriate scale here. But anyway, in this case, it looks like 0 and -6 are my critical points. And since this is less than or equal to or greater than or equal to, I include those critical points because of that equal to. So here I have -6. And how do we show that we include it? Well, by a closed circle. And we're also going to include 0. All right, now at this point, I usually go ahead and I use little arrows to indicate my solution. Well, this first one says x is less than or equal to 0, so I will go ahead and use a little arrow and kind of go that way. So everything to the left is included. And then also this says that x is greater than or equal to -6. So I'm going to do the same thing. I'm going to say, well, it's -6 and everything that is greater than or equal to. Okay? And this is where the and comes in play. This is where the logic comes into play. What do I include here? Because actually, if this was an or, you would include all possible solutions. And you can see that no matter where I choose on this number line, right, something is hitting it. So it'd actually be all real solutions if this was an or. But it's not. This is an and. An and indicates that only solutions exist where these overlap or where they intersect. Okay, so where do these overlap? Well, right here, and this is where I'm going to go ahead and fill in my final solution on this line. So from -6 to 0, those endpoints included and everything in between, that is our solution. It is literally written, that solution, on the number line, though. Okay, so that is the second way to express that solution. And actually, let's go ahead and check out the or while we're at it. All right, so with the or, and this is the green one here. All right, so of course I'm going to put in the appropriate numbers here. In this case, our critical points are -1 and 5, but these critical points are not included because there's no equal. It's just greater than and less than. So I'm going to go ahead and put those points as open circles at -1 and +5. Okay, and I'm going to do the exact same thing. Let's see here. We have x is greater than -1, like this. And we also have, or x is less than +5, like this. Okay, now in this case, since this is an or, where are our actual solutions? Well, it is not where these overlap, but wherever they are solutions. And actually, you can see here, let me use a different color. Maybe we'll use this color here. If I select -3, does that satisfy one of these? Well, yes, this one here fits it right here. If I select +1, well, both of them fit that solution, so that's fine. What if I select -1? Now, this one here, this one at the bottom, it does not satisfy, but notice the one on top, it is satisfied by that one on top. So, what is our actual solution? Well, in this case, There is no number I couldn't pick that this didn't hit. So it actually is all real numbers. So it's the entire real number line, just like that. And so really, if somebody wrote their answer like this over here, um, yeah, that is kind of correct, but is it really in simplified form? Well, that's why we put it on a number line to to clarify. Well, it's really not the solution. Really, x is equal to all real numbers, just like that. That is the symbol for all real numbers. That is our actual solution. Okay, so there we go. That is the number line. Let's go over another solution here. Oh, and by the way, does that make sense? I'm just kind of looking over here because I just made these problems up, and I'm just thinking, well, does that really make sense? Well, take a look over here. If I stopped and thought about this for a second, the absolute value of anything turns anything into a positive, right? And it's saying, well, where is the absolute value of something greater than -3? Well, it doesn't matter what I choose because no matter what, the absolute value of something is going to give me a positive number, which is always going to be greater than -3. So that makes sense that it is all real numbers. So anyways, a little something to point that out. All right, so that's the number line. All right, that is the second way. So first was inequalities. Second way was number line. We could express our solutions. The third way, which is actually the preferred way in Algebra 2 honors in this class, is going to be with interval notation. So interval notation is very nice and concise, and it's pretty easy to use as well. Okay, so let's show it. I'll do the pink one first. All right, so if I wanted to show the solution, in this particular case, it was from the interval from -6 to 0, right? I would write it like this. X is equal to the interval. This is the interval in which I am just putting the endpoints on here. So this interval goes from -6 to 0. Now, at this point, I need to choose whether the parentheses out here are parentheses or box brackets. Okay, the box brackets indicate that those endpoints are included in the solution. If I put parentheses, then that means these endpoints are not included in the solution. In this case, though, this is we're using less than or equal to and greater than or equal to signs, so these need to be box brackets. And by the way, sometimes you could have a situation where one of these is a box bracket, meaning it could be should be included, like this -6, and the 0 may be not included, so it would be a parentheses. But in this case, they are both included. All right, there we go. So again, you can see that this is actually a nice, easy way to write this solution, all right, which is our preferred way. So more often than not, I would be asking you as students to write your solutions in interval notation, although you should know all four ways. Okay. All right, let's do the interval notation for the green one here over on the right. So in this case, I'm going to say x is equal to, now I could do this where I say, well, x is equal to all real numbers. That's the symbol for all real numbers. You could actually write it out, x is equal to all real numbers. Or really the actual interval is this. It is from -infinity on the left up to +infinity on the right of that number line. Now, infinities are never included, so we always put parentheses next to an infinity, okay? All right, and again, with interval notation, you always go, like imagine you're looking at the number line and you always go from left to right. Low numbers on the left to high numbers on the right. All right, it's a common mistake for people to flip these around. All right, so there we go. There's our interval notation, which is our third way of representing inequalities solutions. And then finally, we're going to go over set builder notation, which is something that I rarely ask students to do, but that being said, it is actually the most powerful way that you could express a solution because you can literally build anything that you want. Okay, for example, what if I had a solution that was between 0 and +6, but I only wanted it to include the integers and nothing in between? Well, how would I do that? Well, I couldn't do that with interval notation. It would be a real pain to do it with a number line. I definitely couldn't do it with inequalities, or at least it would be a huge pain because I'd have tons of them. Really, set builder is your only way. So with set builder, you can actually build pretty much anything that you want. Now, in these cases, they're going to look very similar actually to your inequalities. So, but we include a little bit more information. All right. So let's do the pink one first. So with set builder notation, I would say x is equal to, and I'm going to use proper vocab here. So because these symbols do have names. So we're going to say x is equal to the set, which a set looks like this, and we put things inside of the set, items inside the set, or rules. But in this case, I'm going to go ahead and build this out, right? Set builder notation. So x is equal to the set of x such that, that vertical line is such that, and then we say what x is, what group, number group it's a member of, such that x is an element, that little lowercase e epsilon is means it's an element of which number group. In this case, it's the real numbers, okay? And I'm going to put in any other restrictions. So literally right now, if I just left this, it would just be, well, yeah, x is all real numbers. But I need to put in my other restrictions. In this case, x is going to be between -6 and 0. So you could write it with this and notation. I'm just going to go ahead and write it like this. X is greater than or equal to -6 and less than or equal to 0. Okay? So yeah, this is definitely something that is probably looks really foreign to you. But that's okay. It's the first time you've ever seen it. You're not going to be expected to know it much. As the years go on in your math careers, you'll use set builder notation more and more often, right? It's just super flexible. It's the most flexible thing we have. In fact, a little fact here, if you were ever wondering how math was built, how all the rules were built, it didn't start with numbers. It started with sets, okay? It started with a set, all right? Using set builder notation. Anyway, okay, last one here is how would I express this answer in green here? Well, actually, we did say that this answer is all real numbers. So just putting that into set builder notation, we again would say x is equal to the set of x such that, sometimes you might see such that look like this. You can put a little colon there if you want. Such that, but I'm just going to keep it as a vertical line, such that x is an element of the real numbers. Do I have to put any other restrictions on here? No, I don't, because like we said, we showed that actually, technically speaking, this here is, it should be all real numbers. Okay, so I will just close off my set. So again, I'm going to read this. X is equal to the set of x such that x is an element of all real numbers. So it is just all reals at that point in time. Okay. All right, guys. So that is it. That is those are a couple of explanations or a couple of examples and the steps for how to solve absolute value inequalities. Hopefully you got something out of this lesson. And I guess I will see you in the next one. Have a good one. Bye now.